Did you know that the road you're driving on could be made from the very same asphalt that once paved another highway years ago? That's right. You see, every year, a staggering 100 million tons of asphalt are recycled worldwide, thanks to cutting-edge technologies at major facilities like Aztec's double-barrel technology and Germany's Benninghoven asphalt plants. Regions like Europe and Japan have impressive recycling programs, with Japan reusing over 98% of its asphalt. But how long does asphalt actually last? Well, typically a highly maintained asphalt road can serve you for 15 to 20 years, though factors like climate and traffic can influence this. When it comes to choosing between asphalt and concrete, the benefits are clear. Asphalt is not only more cost-effective, but also better for the environment due to its recyclability and adaptability to various weather conditions. Curious about how this old road material gets a new lease on life? Stick around, this transformation process is more fascinating than you might think. Step 1. Assessment and planning. Before any asphalt recycling can begin, there's a crucial step of assessing the existing road surface. Programs like the National Asphalt Pavement Association's Green Initiative in the US and Germany's EAPA Circular Economy have set global standards for sustainable road construction. Engineers and contractors evaluate the condition of the asphalt to determine whether it's suitable for recycling. They analyze factors like the thickness of the asphalt layers, the level of wear and tear, and the presence of any contaminants or harmful substances that could affect the quality of the recycled material. This assessment helps in planning the removal process and estimating the amount of reclaimed asphalt pavement, RAP, that can be harvested. Planning also involves identifying the type of new road surface needed and determining the mix of materials required. Engineers decide whether the old asphalt will be used for the base layer or if it will be incorporated into the surface layer, influencing the choice of additional materials. Step 2. Removal of old asphalt. The removal of old asphalt, known as milling, is a critical step in the asphalt recycling process that demands precision and careful execution. Milling involves the use of specialized machinery to remove the top layer of asphalt from an existing road surface. This machine, called a cold planer or milling machine, plays a crucial role in this process. Equipped with a large rotating drum lined with sharp, hardened steel teeth, the cold planer grinds and scrapes away the asphalt layer, often to a predetermined depth that can range from a few inches to the entire asphalt layer, depending on the road's condition and the project's requirements. The milling process is not just about removing the old asphalt, it's also about preserving the underlying road layers. The precision of the milling machine ensures that only the intended layer of asphalt is removed, leaving the underlying base intact and undamaged. The removed RAP is collected by the milling machine and conveyed directly into trucks for transportation to the recycling facility or temporary storage. One of the key advantages of milling is that it allows for the recycling of asphalt while keeping the roadbed stable. This method reduces the environmental impact by minimizing waste and conserving natural resources. Moreover, milling is highly efficient. It can be done while the road remains open to traffic, reducing the inconvenience for road users. The process also helps in leveling the road surface, removing irregularities, and providing a smooth, even base for the new layer of asphalt. After the old asphalt has been milled, the RAP is loaded into trucks and transported to a recycling facility. Specialized trucks with compartments are often used to protect the RAP from the elements and ensure that it remains in a condition suitable for recycling. At the recycling facility, the RAP is unloaded and stored in large stockpiles, where it is kept until it is ready to be processed. Proper storage is essential to prevent any contamination, as the RAP must be kept free of debris, moisture, and other foreign materials that could affect the quality of the final product. Step 3. Crushing and screening. In the recycling facility, the RAP undergoes a critical transformation process: crushing and screening. Initially, it is fed into a crusher, which is a specialized machine designed to break down the large chunks of asphalt into smaller, more manageable pieces. The crusher's design typically involves heavy-duty jaws or impact hammers that exert significant force to crush the asphalt. The goal is to reduce the material to a size that is suitable for further processing and mixing with new materials. The crushing process is highly controlled to ensure that the resulting particles are uniform in size. After the initial crushing, the material moves on to the screening phase. Screening involves passing the crushed asphalt through a series of sieves or screens with different mesh sizes. This process separates the material into various grades based on particle size. Smaller particles are typically preferred for surface layers of asphalt, while larger particles might be used in base layers, depending on the specific requirements of the road project. Any oversized particles that do not pass through the screens are sent back for recrushing. This ensures that all the material meets the necessary size specifications. The screening process is also critical for removing any impurities or foreign materials that might have been picked up during the milling process, such as dirt, gravel, or debris. Step 4. Mixing with new materials. Once the RAP has been properly crushed and screened, it is ready to be combined with new materials to create a fresh asphalt mix. This is where the magic happens. Old meets new to produce a durable, cost-effective road surface. In this step, RAP is carefully measured and introduced into the mix alongside fresh asphalt binder, which acts as the glue holding the entire mixture together. The binder is a crucial component, determining the asphalt's flexibility, adhesion, and overall performance. Additionally, new aggregates, crushed stone, gravel, and sand are added to enhance the structural integrity and texture of the asphalt. The proportion of RAP used in the mix can vary significantly depending on the specific requirements of the road project. Typically, the percentage of RAP ranges from 10 to 30%, but some advanced techniques allow for higher percentages, sometimes up to 50% or more. The ability to incorporate high levels of RAP is a significant advantage, as it reduces the need for new materials and lowers the environmental impact of road construction. During the mixing process, rejuvenating agents may be added to the mix. These agents help restore the aged binder in the RAP, improving its viscosity and performance. This is especially important when using higher percentages of RAP, as it ensures that the recycled asphalt performs as well as new materials would. Step 5. Heating and conditioning. After the materials are mixed, the next step involves heating and conditioning the new asphalt mixture. In a hot mix asphalt plant, the blend is heated to a temperature between 300 and 350 degrees Fahrenheit, which is equivalent to 150 to 175 degrees Celsius. This heating process is essential for making the asphalt pliable and workable, allowing it to be easily laid down on the road surface. During heating, the materials are thoroughly conditioned to ensure that the old asphalt is evenly distributed within the mix. The conditioned mix is then kept at a specific temperature until it's ready for transport to the construction site. The transportation process must be carefully managed to maintain the mix's temperature and consistency. Asphalt trucks, equipped with insulated bodies, are typically used to transport the hot mix. These trucks ensure that the asphalt remains at the optimal temperature during the journey, preventing premature cooling or setting, which could affect the material's workability. Depending on the distance between the plant and the site, the transportation time can vary, but the goal is to deliver the asphalt mix as quickly as possible to maintain its quality. Step 6. Laying down the new asphalt. At the construction site, the hot recycled asphalt mix is laid down on the prepared roadbed. Paving machines spread the asphalt evenly across the road surface, ensuring that it's distributed to the required thickness. The paving process is carefully controlled to avoid any unevenness or segregation in the mix, which could lead to defects in the finished road. The asphalt is typically laid in layers, with the thickness of each layer depending on the road's design and the traffic load it will carry. The laid asphalt is then smoothed out and compacted to achieve the desired surface texture and density. Compaction is done using heavy roller machines that press the asphalt mix, eliminating air pockets and ensuring that the material is tightly packed. Proper compaction is critical for the durability and longevity of the road surface, as it helps to prevent issues like rutting, cracking, and water infiltration. The compaction process also gives the road its final smooth finish, making it ready for use. In some cases, a final layer of surface treatment, such as a sealant, may be applied to enhance the road's durability and appearance. Engineers and quality control teams conduct various tests to ensure that the newly laid asphalt meets all the required standards and specifications. These tests may include measuring the density, smoothness, and compaction of the asphalt, as well as checking for any defects or irregularities. The quality control process also involves testing the recycled asphalt mix for its resistance to wear, cracking, and other forms of degradation. Any issues identified during testing are addressed before the road is open to traffic, ensuring that the final product is of the highest quality. And there you have it. The next time you're cruising down the highway, remember, you might just be driving on a road that has more lives than a cat.